So hello everybody, welcome to another show. I'm going to start right now, though this is going to be recorded, so if people are still joining, that is fine. It's going to be recorded and it will be put in the usual spot where all the videos are normally put. So today we have a really good, really fun, exciting show. We are going to create a web application called, Will I Golf Tomorrow? It's basically to predict whether or not we're going to golf tomorrow, and it's going to use a naive-based model, and it's going to use real-time weather forecast. So that is really cool. It will also, we're going to then build a simple wrapper around it, simple web wrapper, and then port that to the web. So this is the whole point of everything we're doing here. This is part of the series I've been doing for a while now. We started doing HTML5 up templates so you can quickly get a landing page up and going on the internet. Beautiful things, beautiful professional looking pages. Contact us, email forms. We've done, dynamic charting with Chart.js, with Matplotlib. We've also done Stripe checkout. That was really cool. So you can take subscriptions as well as payments and sell things. Google Maps, all sorts of things. Even another one I'm releasing pretty soon on Discuss message board. So you can get a community built. Very important. Here, we're going to do this naive-based model. But this is all about, quickly, and it's actually, all this is going to accumulate eventually in my book called MVP Light Stack Field Guide. That's going to be out hopefully by the end of October. But the idea here is that it's all about taking, it's catering to the data scientists, the developers who work with Python a lot and who develop in TensorFlow and scikit-learn, who develop with NLTK, whatever you're working on, and to quickly take that and port it to the web, not in days or weeks, but in hours. That's the whole point, because we're working with Flask, we're working with Python-friendly cloud servers that is super easy to take, a programming project that's already in Python and port it to Flask, because it's in Python as well, and then share it to the world so people can enjoy it, so you can sell it, whatever you want to do. That's what an MVP is. So MVP means minimum viable product, and it's where you quickly get something out in the internet, just like this golfing app that we're going to build today, and to see if people are interested in it. It's very cheap to host, so you can leave it there for a few weeks, and if after a while nobody likes it, then you just pull it down, right? And you use that cloud instance for another project. That's the whole idea. You can quickly get them up and running. So this is viralml.com. So welcome. My name is Manuel Amunatigi, your host as usual. Sign up for my newsletter. It's right here in the middle of the page. And you will see the code for this video is actually on the viralml.com page, right underneath the Bayes theorem web app intro that I did. It's right here. Just click on there and you'll get the source code. Eventually, it's going to be put where I normally put my source code, which is under channels, and where this video will be saved once it's finished, and under web apps. So channels, web applications, and it's going to be part 8 of this series. And there you'll find the source code and everything you need. So let's get going here. So we're going to be using naive Bayes. So naive Bayes is huge. It's been around since the 60s. It's very popular for many reasons. One, it's popular because it's considered naive, meaning that every feature you add in there is considered independent of each other. So it is naive because nothing really is independent of each other. Like in a golf, like we're going to be predicting whether somebody's going to golf or not using environmental readings like temperature, wind, humidity, and those things are never independent from each other. But it simplifies the math tremendously if you consider them independent. So that's what's really cool, and that's why people love them. So we're going to be using a Bayes classification model. So it's, again, a derivative of naive Bayes. And imagine that it's a kind of, a bunch of buckets where you put a lot of different environmental readings of whether somebody golfed or not. And each one, it was sunny, low humidity, we went golfing. One was raining, it was cold, we didn't go golfing. You have a bunch of these buckets, and naive Bayes will use probabilities to figure out if, given things it's seen in the past and maybe new factors, or mixing and matching them, it's going to calculate the probability of what it thinks whether or not you'll go golfing. And that's what we're doing. That's what Bayes classification is all about. I put the math here for those who are interested. It's from Wikipedia, and as well as a great link here from RapidMiner, which really goes into Bayes classification. It's a funny video, so if you're interested in more of how it works and the background of it, I recommend going to it. So we're not going to do any math here. We're simply going to use scikit-learn's Gaussian and naive Bayes, Gaussian NB. It's super simple to use. It's just like anything on scikit-learn. You have a .fit method, you have a .predict method, etc. So super simple to use. Now the data. We're going to be using the Gulf weather data. This is a famous data set. I always say it's famous because whenever somebody is doing class on Bayesian classification, they always use this golf data set, whether it's basically a series of temperature readings, environmental readings, and whether somebody went golfing or not. So very simple. It's from Gerard Nico. Here is his blog if you want to get more details about this. But we can simply take this code, and that's what I recommend you do. You just kind of copy and paste as I go along, open a Jupyter notebook, and kind of paste it, right? It's super simple. So here, we're importing pandas and numpy as the usuals. I'm creating the headers. So we have, as you can see, outlook, temperature numeric, temperature nominal, humidity numeric, humidity nominal, windy, and whether or not we will play. This is our outcome variable. So that's an important one. And here are the observations. There are only 14 observations. So take this with a grain of salt. It's a bit of a toy. It's basically a toy data set. We're going to kind of take all of this. This is a list of lists. We're going to force everything into a data frame, pass it the headers, and let's look at what the output looks like. If I can type. And very simple looking data set. So we have outlook, which is kind of means whether overcast, sunny, rainy. We have a temperature numeric, temperature nominal, and I know these resemble each other a bit. And I think if this was a production model, I would choose one over the other. I wouldn't have them both. Same thing with humidity numeric, humidity nominal. One is kind of a continuous variable. One is a category. But I'm keeping them both because I think it's interesting for people who may be new to this to know how to deal with both numerical and categorical and know how to kind of use each together. We're going to have to use them. I'll show you in a second. And whether it's windy or not, and whether you play golf or not. So these windy and play were originally a true false, and I simply cast those to a type integer. So you can cast a type integer, true false, which are right here. You can cast those to integers and you get them into a numeric format. So there's a few things we want to do before we get going. A little simple, EDA. Like an exploration of the data. So the first one, of course, is to look at let's go info. Get info on your data, and it's going to tell you what are the data types of of this data set. We see that we have a mixture of objects and int 64s, right? So a model, you can model numbers all day long. Models love numbers. It doesn't like objects. Object in this case could be a date time, could be text, could be a category that's text. It could be a numerical value that's text, right? Maybe dollar signs, or maybe they have some quotes on them, right? It does not know how to deal with objects, so you have to do something with objects. Integers, floats, you can model, no problem. The question is, are you sure they really are integers? Because think about it. If you have a category where it's happy, neutral, and sad, and it was 1, 2, 3, you probably could model that. But what if it's a zip code? Zip code are all numbers, but you can't model that because zip codes are really categories. There's nothing linear about a zip code. So good thing we don't have to deal with that, but we have to investigate what are these three objects. And it's pretty simple. They're obviously the outlook because it's a text category, temperature nominal, also text category, and humidity nominal, text category. We're going to have to do something about that. And let's take a quick peek at our numerical values. And that's super simple to do. I use the describe function. And that's also very useful. We see, for example, in the temperature numeric, we see that the minimum value is 64, the maximum is 85. So that tells you, right, this is a Fahrenheit, this is a temperature range. It seems pretty normal. So here, not only can you infer what it is, but you can also look for outliers. If you had, a million degrees or, a big negative number, it probably would be an outlier, especially on a golf course. Same thing with humidity, windy, same thing. Play, that's interesting as well. This is our outcome variable that's now cast as an integer, 0 or 1. We can see by looking at the mean of your outcome variable, it is 0.64, so 64%. So we know that's closer to 1. That means that there are more ones than zeros. And the data set contains more cases of people golfing than not golfing, and by 64%. So we can see it's not, if it's not a balanced data set, it's not 50-50. So right off the bat, it's very few observation, and it's a little heavy on the people who are playing golf. So it tells you that this is going to be it's a tough data set, but it's going to work fine for us. Now we need to deal with these categorical data, right? So we're going to let me cut this one here. There's a great function in Python called called get dummies. So it's part of pandas, and this is a panda data frame we've created, right? The data we've created, we force it into a pandas data frame. So now we can inherit all these panda functions and get our work done very easily. So panda get dummies, what it does is you tell it, this is a categorical data feature. I want you to binarize it or one hot encode it, or however you want to call it. Basically, if you have a column where it says, you are happy, sad, neutral, you flip this. And instead of having one column, you'll have 3 columns, and one will be happy, one will be sad, one will be neutral. And if it's happy, it'll be a 1, and the other 2 will be zeros. And if you have these 3 columns, you could also remove one and only have 2. You're either, if you're not happy and you're not sad, then you're automatically neutral. And some models, they prefer not having that redundancy, like a regression model prefers that. Bayesian should be fine, and I work a lot with models like XGBoost, and XGBoost, doesn't care, right? You could throw cold water at the XGBoost and it will still work. But so that's why we're not going to worry about that. But you can remove that, basically saying drop first, and it will drop the first one. So if there's 3 different categories, it'll only return 2 columns. So we're not going to deal with that. It's about the dummy trap. This is something that you'll see in regression models. So here we simply say, pass that data set that we've already created before, right? Remember, it looks like this, right? So it's got our features, and 3 of them have text, our categoricals with text. And we are simply going to pass them to this get dummies function. We're going to say, I want these 3 features, these 3 columns, binarized into their own columns. And when you run it, look at that. Now, instead of having, let's look at the overcast column. We had overcast. We had Outlook was overcast, rainy, and I think there's one sunny. Now we have Outlook overcast, 1s and 0s. Outlook rainy, 1s and 0s. Outlook sunny, 1s and 0s, right? So this is all numerical. Now we can model this all day long, right? This is super easy to work with. Okay, so what do we have to do next? We're going to do the modeling. We're going to do the naive-based modeling. And if you are missing some of these libraries that are important, just install them, right? You just cut and paste the error, put it in Google, and it'll tell you how you pip install them depending on your OS, whether it's Windows or Mac. So a few things I like to do before I model, I like to have a clear idea of what my feature set is. So the feature set is what you're going to be using to predict. It's not your outcome variable. So I create this feature set, which are all the features minus the outcome feature, right? Minus the outcome column. And it returns temperature numeric, blah, 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 blah. You see, it has all the ones we created minus play. So it's simply a comprehension. I say, give me all the feature names from, I'm doing a list golf data frame ready, get everything but play. And now this gives me an easy way of kind of directing a training data set versus the outcome set. And that's what we're doing here. Now we're going to create 2 data sets, a training and a testing. So a training data set is going to be the first column. Sorry, testing. Testing, because it's a small data set, we only have 14 rows. I'm going to take the first row and say that's testing, and the next 13 rows as training, right? So there's different ways you could do it. You could have randomly looped through it a bunch of times or 13 times so that everybody has a chance to be test. But in case, we're going to keep it simple. The first row, remember, is just for testing. So if we look at the data set, this row is testing, and we happen to be playing golf that day. And all the other rows, the 13 other rows, are for training the model. So to start a Gaussian NB model, super simple. You declare a variable where you pass it a Gaussian NB model, and then you fit that variable, that Gaussian model is ready to go. You fit it by passing it your training data set, basically all the features without the outcome variable, comma, the outcome variable. Is that simple? And that returns a trained model, and then you can score it. You can see if that worked well or not. You then go naive-base.score, where you pass it your testing data set and the outcome variable, right? So we're going to run this. Remember, we have only 1 in there, and it says an accuracy of 100% sure that this row, this set of temperatures, is going to allow you to go golfing tomorrow. So now we can use the predict functions that are available. Well, first, let's verify that we have this correct, right? So it's super easy. Outlet testing data, right? And we can go. I think it's play. Yes, we are playing golf tomorrow, so we know we're good. The model got that one correct. Now let's predict it. We're going to call it a predict function from naive base. So you take your trained model, naive base is trained now, and you call the .predict function. And here you pass it your, imagine it's live data where you don't know if you're going to golf tomorrow or not. So there's no outcome. You don't have to pass it the outcome because it doesn't care. It's actually giving you a prediction. It's not doing, if you want to score something and get an accuracy score, you would pass it your data, the features, plus an outcome variable, right? A ground truth. Here we don't have that. We just run this and it's going to give you a guess. Yep. It says you are golfing tomorrow. And you can also do predict proba to get the probabilities. And that's going to give you the probabilities of golfing and the probabilities of not golfing and of golfing. So 0% chance of not golfing, 1% chance of golfing. And that might be more interesting if, it's like a 0.25 chance not golfing, 0.75 chance golfing, right? And you can start doing things. You can say, okay, we're not so certain. Here, we're pretty certain that we're going to go golfing tomorrow. Okay, so now let's predict new data. We're going to invent new data. So if we check out all our features, we can do a list on, let's take the testing data, that will work. Actually, we don't need to play. We don't really care about the playing part because we're going to predict it. So let's go, let me just copy this. So if you want to create new data, so basically you want to ask our trained model whether it's going to, whether you're going to golf tomorrow or not using data it has never seen before, you need to come up with a temperature numeric, humidity numeric, all of these you need to come up with. And that's exactly what I did. I created a new set of data. So basically one more row of data of completely invented data. And as you can see, temperature numeric, I put 80 degrees and a whole bunch of other things. Let's find out if we go golfing tomorrow. So I'm predicting, will we go golfing tomorrow? This is the head. Now we're going to call the predict function for this data. It's right here. So we say naive.base.predict and we pass it our invented data, right? Super simple. And yes, it says we're going to golf tomorrow. What if we change the 80 degrees? We know the first value is temperature numeric. What if we made this a cold day? I'm going to make it 40 degrees Fahrenheit. So now it's 40 degrees. Are we golfing tomorrow? No, we're not golfing tomorrow. It's too cold. We're not golfing. So it looks like the model is somewhat working. We're looking good. Now let's kind of remember yielding a prediction for a customer or somebody who is going to use your web app. You yield some kind of value, 0.75%. If you give 0.75% chance of 0.75 or 75% chance of golfing tomorrow, that's it's pretty dry. So if you always want to help the customer digest the information or your web user digest the information. So we can do some things because it's the predict function returns a 1 and 0. That's all it's going to return, a 1 and 0. Proba will return different things, the probability, but predict will only return a 1 or 0 whether you're going to golf tomorrow. So you can then you can pass it the Boolean function, and it's going to you can translate that 0 to 1 into a true false, and suddenly you can write something. Will I golf tomorrow? And you pass it the Boolean answer of your prediction's result, false. And you can even say, the answer is, will I golf tomorrow? The answer is false. You're not going to golf tomorrow. So you always want to kind of start building things so that the information is digestible for somebody. So keep that in mind, right? This is what we're doing here. This is the end product that we're going to build today. Where the controls are simple. You simply enter a city, you simply enter a time slot, will you golf, yes or no, and it returns an image. Yes, somebody is golfing with like little icons and some information. So that's a way of really, you don't want to assume somebody knows statistics or math in order to use your web app. No, they just want to know if they're going to golf tomorrow or not. So you want to make it as intuitive as possible. That's kind of the idea of starting to decorate your answers into ways that are digestible and consumable by everyday people who want to use this. Okay, so now obviously, right, we're going to need live weather. That's probably the most important. After the model is trained, now we want to be able to put live weather from around the world to find out if you're going to golf tomorrow or not. So we're going to be using, this is incredible, it's the openweathermap.org. Click on the link there, and it's going to bring you here. It's free, but you need to sign up. So go ahead, sign up if you want to try this service out, and you can. It will give you an API key with which then you can get weather around the world and also weather forecasts from around the world. So we're going to be using the forecast. So let me quickly show you how it works. And I'm going to make a whole video about the open weather map stuff because it definitely deserves more explanation, and we're just going to fly over this. You will need URL lib, you'll need JSON because it returns a JSON string. It's a REST API service where you pass it, I want the weather for Barcelona, and you give it your API key, which I have mine saved in memory, and it's going to return your typical JSON string, as you can see here. You can see you have, it gives you the latitude and longitude. It says it's going to be cloudy. What else does it say? It confirms the town, this kind of stuff. But the problem here, it gives you wind, clouds, all sorts, humidity. It gives you temperature. The temperature is in here. See, it's in Kelvin. So we're going to have to change that into Fahrenheit or Celsius, whatever you want to use, because nobody knows this. But this is weather. We don't want weather, right? This is the weather right now. So this is kind of like eyes somewhere around the world. How is things now? We want to know how are things going to be in the future, especially tomorrow, right? Because remember, we want to get to a place where you can put a country in and dial up a time range, and that's when we know whether you're going to golf or not. So that's not going to work for us. So there's another function, still a REST API call, still very simple to do. And let me just cut this whole thing and explain how it goes. And here it is, it's the forecast. So it's the same thing, api.openweather.org/data/2.5/forecast, and you give it a location and you give it your API key. But here you're calling forecast. So forecast is going to return a huge amount of information. So that's why it's a little bit more difficult to work with. But when you call this, it returns this huge string of JSON, and I'm going to give you a peek of how it works, just so you have an understanding. But it gives you, I think, hundreds and hundreds of data points. But what it does is it gives you data for now to 3 hours in the future. That 3 hours plus 3 more hours. So basically 3-hour chunks going into the future for Seattle. So next 3 hours, the following 3 hours, the following 3 hours. And I think it does that 40 times. So you have a few days of 3-hour forecast. And that's what we want. And because on the app, we are doing 6 a.m. To 9 a.m., 9 a.m. to 12 p.m. We're doing it in 3-hour chunks. We need to kind of figure out exactly what corresponds to where. And what I did here is I'm saying, loop through everything that it returns and find me the first instance of 6 a.m. and return me the counter. How many times do you have to loop? And now I know I have 6 a.m., so I just have to go to the next cell and I'll have 9 a.m., the next one, 12 p.m., and so on and so forth. And that's all I'm doing, and I'm going to keep it simple. I'm not going to go too much in depth, but like, for example, now, if you want just to get the 6 a.m. data, I can do time start, which is the counter that told me where the 6 a.m. is, and now I can confirm I have the 6 a.m. So in Seattle, we know it's going to be, in Kelvin, it's going to be 279. We'll have to translate that. The humidity will be 78. It'll be cloudy, and the wind speeds, blah, 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 right? So now we have forecasts by chunks of time for Seattle, or for wherever you dial it. And as you can see, we're starting to look, you can see how our app is functioning, right? How we're translating that functionality into a weather data for specific areas that we can feed into our Bayesian model and find out if we're going to golf or not tomorrow. Okay. So let's see, different times here. And please go through the Jupyter Notebook if you want to dig into more details. So we do have a little bit of work to do, unfortunately, because we now need to translate that data, what the open weather map returns, to the Gulf weather data. So however you're modeling your data in the Bayesian model, you have to translate any external data to that to comply to that form in order to give you an accurate prediction. If you give it garbage or it's mixed up, the Bayesian model won't know what to do. So we need to translate everything that was returned by the open weather map into exactly this format. The only way we can get a good prediction is if we translate open weather map into this format. And that's what we're going to do. It should be fairly straightforward. So there's a few things we had to do. Let me just show you. We know that the temperature numeric and temperature nominal, that's why it's important to have both, because now we can compare the numeric values with the nominal values. And I can say that whenever it's cool, the temperature numeric is between 64 and 69. When it's hot, 80 and 85. When it's mild, 70 and 75. So anyways, then it's just a question of building a little function that whenever open weather map returns, let's say 65, we can say, oh, it's cool. So that's how we're translating the open weather data into our Bayesian model data, the Gulf weather data set. Same thing for humidity. We know that the high range goes between 85 and 95. When you compare the nominal with the humidity nominal with the humidity numeric, and the normal goes between 65 and 80. So there we know that, right? We can easily work with that. Humidity. The humidity, same thing. We are looking at the humidity of over 80 is considered high, under 80 is considered normal, and that's how we do it. Temperature, same deal. This is kind of the function that we did from our EDA research. Under 70, we say it's cool. under 80, we say it's mild. Everything else is considered hot, right? So I mean, you're starting to get understand what I'm doing. It's returning the data in Kelvin. So we have, this is the formula to translate the data to Fahrenheit, from Kelvins to Fahrenheit, right? So that's what we have to do. Okay, so now let me scroll back up a little bit and see if I can. Well, no, I'm just going to keep going. We'll run this afterwards. There's a cool thing. The open weather map also yields these cool little icons. You see on the right and left of yes, we're going to golf. It tells you the type of weather through an icon. So I thought, what a great way of let's get that information. Like for example, for sunny, it gives you this sunny icon, and it's very easy to get. You get it through. You simply need to call this link. openweathermap.org image/w/ and the icon code. And the icon code is returned in the JSON string. As you can see, it's somewhere here. Where are you? Icon. So you have the icon code, you take it, and you slap that icon code to that link. And it returns a cool little image that you can use in your web app. So we're going to do the same thing. So now we can, now it's easy for us. We have ways of basically translating all that information from the open weather map into the same format as the Bayesian, as our Bayesian model. And that's exactly what we're doing here. We are going to call, let me just run this one separately here. Let's say, actually I'm going to walk you through this one. Let's say our location is Tokyo. We want to find the weather in Tokyo. So we call the forecasting REST API call. We pass it our app ID, the location, and then we get, this huge weather JSON string. Same thing we did before. We find the first instance of 6 a.m. We break, and then this is kind of a map. 6 a.m. to 9 a.m. is basically whatever this timestamp start key is. 9 to 12 is the timestamp start +1, and so on and so forth. And here we have now the way of dialing each one of these time segments to know whether or not we're going to golf. Then we, for this case, we're going to ask for 12 p.m. We're going to translate our temperatures, our humidity, our outlook. We're going to get the icon. We're going to get, everything. So here we're basically creating a massive function to translate all the open weather map data to the Bayesian model map. And I'm going to run this. Hopefully it works. And here it is. It has returned this information. So we know in Tokyo at that time range it's going to be 80.7 degrees. It's going to be no wind. Let's see if we're going to golf based on this situation. Same thing, we pass it to our model. 0 and 1, we are definitely 100% going to golf tomorrow. And let's let's paint that information as as a more digestible way. That's what I was talking about before, right? So here we now say there is a 100% chance of golfing tomorrow. Even better would probably be to put this into some kind of rounding. That would be even nicer. Let's see if this works. No, it doesn't work. Anyways, maybe see if I can remove this. Nope. But that'd be nicer to kind of remove this excess of data. But we do that in here, right? Yes, we go. We kind of limit that number to 2 digits after the decimal point. Kind of simplifies things, cleans it up a bit. But the idea always is to clean it up, make it digestible for our end user. Also, if it's a composed with spaces, whenever you're dealing with on the web, you can do, for example, New York City if you want. New York City. It can handle, actually, I think this one likes to be New York. Let's try New York. New York here. It can handle blank spaces, but you have to use this the urllib.parse.quote to kind of take care of the spaces. You see how it kind of fills up the spaces with special characters, and that's important. Otherwise, it's gonna give you errors. So this is kind of the little things we do inside our HTML code and our Flask code. Okay, so now let's go to the fun part, right? So I know I'm flying over. I'm giving you guys going through a lot of stuff. It's already 7:30, so I want to spend maybe another 15 minutes max because I don't want to, to be too long. People after a while, it's too long. People kind of give up on this, and can't blame them. Let's port this on Flask, and it is super easy. This is the easy part. So Flask, as you know, is a web serving technology, and you can run it locally. That's what we're going to do. So I am running this locally. As you can see, the address here, it's local, and it's super easy to do. So what you need to do is you need to create a folder structure. I named mine Will I Golf Tomorrow, and I created all these folders. So whenever you have Flask, you have a flask.py file. In this case, it's called flask.app_app.py, and it's your controlling code. It's what does the web serving. Basically, it's find out where did you come from and where do you want to go, and do you need any dynamic data. If you do, it's going to create the data and inject it and pass that out as an HTML file so that you can visualize it. There are two types of folders usually underneath the Flask structure. One is a static folder, as its name implies, a static information. So we have images, you can have CSVs, whatever you want that's not dynamic, right? You just serve it the way it is. And then you have templates. Templates hold dynamic information. So they usually hold things like HTML files, which are going to be an HTML skeleton with some spots that will take dynamic HTML data. Sorry, dynamic Python data. And I'll show you how that works in a quick second. And that's basically what you do here. You create a Flask app, a static folder. Underneath the static folder, you create an images folder, and I'm going to put these two images. That's super easy to do. Here are the images. Right click, go save image as, and put them in here. You have the golfing image and the non-golfing image. It's kind of nice to give a little variety, right? And you have a template folder where you're going to put the index.html file. So let me show you how this works. This is pretty simple. And the way I'm going to do this, you can simply take the Python code. This is create your flask.app.api file and cut and paste this entire thing. It's a bit long. Cut and paste that entire code, put it in your flask_app.py file. Okay, save that, and do the same thing for your HTML file. Take the whole thing, copy it, and save that into your index.html file under your templates folder. So you should, in the end, have something like this. And then it's simply, basically calling it to be able to visualize it. And the best way to do it is to, for me, I'm going to show you how it works. The only bummer here is that I'm kind of stuck in this window, so it's hard for me to show you the terminal window, because I don't have access to the terminal window here, or you won't see it in my filming software. But basically, once you have this entire thing done, if you're on a Mac, you open a terminal window in the same folder as your flask.app_app.py, and you simply do Python 3 or Python, whatever, however you're calling a Python folder, Python program, and simply space flask_app.py, and it's gonna your terminal window will return a URL, a very simple URL. In this case, it's for me, it's this one, right? It's this one, and then you'll be able to run it. So I'm gonna do something. I'm gonna do something a little bit different here. I'm gonna show you how it works on Python Anywhere. So if you're not familiar with Python Anywhere, it's really cool. Python Anywhere is the same thing as it's basically a cloud instance, so you can run your code in the cloud. It's free. So simply go to Python Anywhere, get an account if you want to try it. And let me I'm gonna upload this golfing set just exactly the same way you would do it locally. So when you open it, it's a free account. You open it, there's nothing. You go add a new web app, and I go yes. I want to go a Flask web app. So I'm going through the wizard. Oops, I need to do Python 3.7, and I'm gonna go with all the defaults. So I'm basically creating an instance on Python Anywhere in the cloud. It's gonna create it, and it's going to return a Python Anywhere link. And this is basically whatever. This is your account number.python anywhere is what you have. And look at this. We're now live on the internet. And very briefly, I can show you the code here. Let's go here. It creates a folder called My Site. It creates this flask_app.py. And this is kind of the brains of our web serving. And you can change the message. I could say, this is manual, right? With exclamation point. And you need to always, whenever you're working on a web server, you need to refresh the web server. So here I'm refreshing it, but you could also do that in the web page. Oops. The green button is the same thing. That's how you refresh it. Refresh it to make sure your code is updated. And I'm going to go back to my link on the internet. And now I have this is manual, right? So we see we just changed the code on our web server on Python Anywhere and we update it. So now what I'm going to do is I'm going to recreate our golfing code right here on Python Anywhere. So for starters, we don't want this Flask underscore app.py. We want the one we created. So I'm going to upload it. And at the end, I'll briefly go through both the Flask API and the HTML file so you see what's going on. I'm going to create, this is exactly the same way you would do it on your own machine, on your own local machine. I'm going to create a static folder. Under the static folder, I'm going to create an images folder. And here I'm going to upload, you guess what, right? Our 2 images. You can't see that, unfortunately. But I am uploading, it doesn't show the pop-up in the software. I'm using OBS for filming, and it just shows that window. It doesn't show other things, so that's fine. And as you can see now, I've uploaded the Go Golf and No Golf images. So go back to your My Site, and now we need to have a templates folder, right? Templates, plural. And here I'm gonna upload my template file. So go to here, images, no. Oops, Flask. Okay, you don't see this, but the pop-up is there. And here. So now, right, I have created my site. It has a static and a templates. So this should look exactly like your folder structure that you did locally, right? And now I'm ready to go. All I need to do, right, as usual, is refresh the web server because I updated things. It takes a little bit longer because it's got a little bit more to do. And then you know, simply click your link, your live link, and look at that. It's now on the internet. You can go there now if you're live, right? There's a few people live, yeah. You can go, I'm gonna take et.pythonanywhere.com and you can play around with it. So I'm gonna go with, let's go with Boston. Choose a time range, 9 to 12. Let's see if we're gonna golf. Yes, we're gonna golf. Let's try Paris, same time. Yes, okay. I wanna find somewhere where we're not gonna golf. Let's try Madrid. Maybe we won't. Yeah, we're golfing. We're basically golfing everywhere. Let me try very late at night in Madrid. Okay. Let's try London. Late at night. There, finally we got a no. Okay, we're not going to golf in London. Sorry, no. It looks like there's a very low, 0.06 chance. Why? Oh, because it's rain. Yeah, we're definitely not going to go golfing when it rains. And you get the bag that's like lonely. Okay. That's what I want to show you. So before I end this video, I want to show you very briefly what's going on. Okay, so let me open the Flask app, and we're going to look at it through the Flask. We're not going to look at it through the Jupyter Notebook because it colors things. It's a little nicer. Oops, that was the key. Let's see. So I'm not supposed to show my key, so I'll have to change this after this video. But I declare the key. You create an app instance of Flask, right? So we're declaring Flask. And now you have your Flask. Now I'm creating everything we walk through in the Jupyter Notebook, right? I'm creating it here. This is the code that every time we create it, it's going to build the golf dataset. It's building it dynamically, right? And it returns the golf dataset. So who is calling this? Let's find out. So there is a cool handy function in Flask. And again, I'm just giving you a quick flyby of Flask. If you're interested in Flask and Python Anywhere, go through the part 1s and part 1 through 7, where we explore a little bit more of this Flask in more detail. But in Flask, you have a decorator of a function. And it's the app.before Flask first request. That means anytime you refresh your web server, it's only going to do this once. That means it's not going to do it every time somebody asks something. It's only going to do it once when the server is refreshed. So it's only going to create the our golf data set. It's going to train the model. As you can see, it's preparing the model. It's even training the model only once. So every time you run the model, it's going to train it, build a data set, train it. So now we have a trained model ready to go. We have 2 global variables, right? The golf data frame and a naive Bayes model. And now This is the decorator for anybody coming to our main domain. So anytime you go, Untitled.python.anywhere, that's where you're going. You're going to, you're routing it to the default, right? So that's basically the domain name. And you're saying it could be a post or a get method. And we're going to say we want to play golf. So I had to kind of create some basic average values, right? The prediction probability is 0.5, the outlook is none, is windy is false, the humidity is 50. Kind of we took the mean values of some of these things and we set them up like defaults. Then if the method is a post, that means that somebody selected the location, so that we know that somebody it's not the first time they went to. Remember when the first time we went to the page, it was blank, it was just, you know, the drop down boxes. Here we know somebody passed something, so we need to go get the location and get a time. There's two features that they can give us: a location and a time. That's the two features that we can that can be passed in. And then we need to call all this code right here, right, is simply going to call the open weather map. So this is dynamically calling the open weather map, finding out if, first of all, is there data, right? That's what we're saying. Did weather.json, did it return anything, right? What if I entered a country it did not recognize? What if I misspell a country? It would return nothing, and it would continue going. So you kind of scroll down, scroll down, scroll down. It's doing all sorts of things. And it would basically return all the average data. So whatever we set up here, right? Whatever our default declarations, that's what it would return. But if there is data, right? Let's say the weather that we do have weather data, then now we can take that weather data, and what do we have to do? We have to transform it so it's in exactly the same state as what you wanted, that the Bayesian model was expecting. So we go through the same things we did before, find out what time tranche they wanted, translate, for example, here, translate the temperatures from Kelvins to Fahrenheit, do the nominal stuff, temperature, humidity, blah, 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 right? And then you get the probabilities. So we're doing a bunch of these, like here we're doing, we're both getting the proba, basically, so that we can return a percentage, right? And we also want to predict. We don't want a percentage, we just want a true false, whether we're going to golf or not, and that's what we're doing it here, right? So there's quite a few things we're doing here, and that's basically all we're doing here. Now let me quickly show you let's go to show you the HTML as well, just so you have a quick app. And I know I'm kind of really rushing through it. I don't want this to be more than, let's say, 45 minutes already. So we're going to quickly go through it here. So the HTML, you know, typical HTML, right? You declare in your head, we are calling a bunch of bootstrap stuff. We're calling the default JS file, so we can have some functionality such as drop downs, such as, I don't think we're using much of that stuff here, but if you had like drop downs, if you had any JavaScript code, you would want to bring the basic, the declaratives to get all the JavaScript stuff. This is how you pass dynamic values in Flask. It's usually a double curly bracket to open, double curly bracket to close. And here you're saying, I'm creating a form, right? So this is a form where somebody can submit something and you pass it the URL, whether you're going to play golf or not. So this tells your Flask underscore app.py what type of URL to return. It will know, right? This is the function play golf. So actually, let me go there. This is the function, not this one, not this one. Play golf, right? This is the default function. So when this will dynamically create the right address to whatever you're posting here. And this function will automatically know that this is the function where Flask needs to pass it. So not only do we know it comes from the domain, it's going to know it has to be given here. And that's how you pass information to it. And the same thing, anytime you see these double curly bracket, these are dynamic data that's injected by the Python, etc., etc. So one last thing I want to show you here. So this is the function that passes the data. And whenever you're done with the data, that's what's pretty cool here. It passes what's called a render template function. The render template takes a template. So it takes our HTML file, which has a bunch of placeholders with a double open bracket, double curly open bracket, double curly close bracket, right? And it will inject all this dynamic information into it. And it will know wherever there's double curly open, double curly close, oh, this is a dynamic value from Flask, right? So that's how you create dynamic web pages, is by melding both Python and Flask. So you have a mixture of basic HTML templates and dynamic data, right? So this is really cool. So again, this is a very high flyover of this type of stuff. I do explain a lot more of this in my books. I like to plug my books at the end of the show. Put my first and last name on Amazon.com, and this is where I go through a lot of this in a lot more detail. Unfortunately, 45 minutes, I realize is just not enough to kind of go through all of this, where we go through a lot of these machine learning projects such as TensorFlow projects, financial projects, and kind of port them to the web, where the whole concept of taking complex ideas and building simple UIs using in the web and on the internet, and so that people can then interact with your Python programs. Because keep in mind that when you think about it, a lot of languages have UIs. Like when you think C#, Java has it, can have it. C# can have a UI if you choose it. Visual Basic.NET can have a UI if you choose it, right? Python doesn't really have it. There's a few things here and there where you can create a UI, but really the powerful UI for Python, really, in my opinion, is the web, because the web has the common controls we all know how to use, right? These are all things that we know how to use. And so if you can blend both the web, the common controls, and the ease of sharing your projects through the internet, which everybody can access through their phones or through their computers, you suddenly have this miracle way of sharing to the world your complex Python models in a simple UI, So again, thanks for watching. I know it's a lot. You will see, if you want to see this video once it's recorded, once it's processed, go to viralml.com, go to channels, and go to web applications. And once I'll clean it up, and I'll add the code and everything, and it'll be another one of these. So I hope you found it useful. I know we went through a lot of material here. It's not easy. It is easy, but it's also a lot of different pieces, and that's the beauty of kind of creating these web apps. It's relatively, once you know the basic Flask, once you know the basic HTML, it's super simple to kind of translate a complex model into something that the entire world can enjoy. Thanks for watching.